So in this question, we're told that a manufacturer produces a storage tank, and the tank is modelled in the shape of a hollow circular cylinder, which is closed at one end, and at the other end it has a hemispherical shell. And we can see this in figure 9. So we see highlighted now is the hemispherical shell, and then highlighted now is the cylinder, the closed cylinder. So we're told that the walls of the tank are assumed to have negligible thickness, and the cylinder has radius of r meters and height of h meters, and the hemisphere has a radius of r meters. And we're given the information that the volume of the tank is 6 meters cubed. In this part of the question, we're asked to show, according to the model, that the surface area of the tank in meters squared is given by this equation here. 12 over r plus 5 over 3 pi r squared. So to begin, we must have a think about how will we work out the surface area. So taking note of that here, we know that the surface area of this will have multiple components. It will have the surface area of the cylinder, it will have the surface area of the base of the cylinder, and it will also have the surface area of the hemisphere on top. So writing this down, we can say that the surface area is going to equal area 1 plus area 2 plus area 3. And just for completeness, we're going to write down what area 1, area 2 and area 3 represent. So we have that the surface area of the cylinder is going to be denoted by A1. We have that the surface area of the base is going to be denoted by A2, and that the surface area of the hemisphere is going to be denoted by A3. So we now have a think, what is the surface area of a cylinder going to be? This is going to be 2 pi r multiplied by h. We know that the area of the base, the surface area of the base of the cylinder, is going to be pi r squared. And then for the surface area of the hemisphere, we know that a sphere has surface area 4 pi r squared, and we have half of that sphere. So therefore, the surface area of this hemisphere is going to be 4 pi r squared divided by 2, which is equal to 2 pi r squared. So then therefore, we can add all these together. So we have that the area is going to be equal to 2 pi r multiplied by the height plus pi r squared plus 2 pi r squared. So then we can just simplify this slightly. We see we have pi r squared and 2 pi r squared. So adding them together, we have that 2 pi r h plus, combining these, 3 pi r squared. So then we now look back at what we're aiming for. We're aiming for something here, but this is in terms of r. But then we have h. So this is where we must have a think. How do we get around this problem? So we're given the volume of the tank, and we know that that is equal to 6 meters cubed. And we know that this volume is going to equal the volume of the cylinder plus the volume of the hemisphere. And then we can work these out. So we know that the volume of a cylinder is going to be pi r squared multiplied by the height. And we know that the volume of a sphere is going to be 4 over 3 pi r cubed. And we have the hemisphere, so we again divide by 2. And this gives us that the volume of the hemisphere is going to be 2 pi r cubed divided by 3. And we know that this is equal to 6 because that's what we're given as the volume. So therefore, on this right hand side, we can take a common factor of pi r squared out. And that leaves us with h plus 2 over 3 r. And that's equal to 6. So we're then going to rearrange this for h. So then we divide both sides by pi r squared. And then to isolate h on its own, we must get rid of this 2 over 3r. And we're going to do this by subtracting it from both sides. So now we have an expression for h. And our expression for h is in terms of r. And this is good because we want to get our area expression in terms of r. So therefore, we can take this equation for h and substitute it in here. So therefore, going back up here, we're going to have that the area is going to be equal to 6 divided by pi r squared, take away 2 over 3r, and we multiply this by 2 pi r, then we add on our 3 pi r squared, and then multiplying out these brackets, we'll then have 6 times 2, which is going to be equal to 12 pi r divided by pi r squared, and then we have negative 2 over 3 r multiplied by 2 pi r, which is going to come out as negative 4 over 3 pi r squared, and then we add on our 3 pi r squared from before. So therefore, we can conclude that the area is going to be equal to, so we have pi r and pi r squared. So the pi's cancel out, and then we have r over r squared, which leaves us with 12 divided by r. And then we have 3 pi r squared negative 4 over 3 pi r squared. And this simplifies to 5 over 3 pi r squared. And then we take a look back at the question and see what it was asking for. It was asking for 12 over r plus 5 over 3 pi r squared, and that's what we have. So we write as required. And that's us completed this question. This question was worth 4 marks, and we receive our first mark for writing out the area as a sum of all the surface areas. So we receive our first mark at that point. We then receive our second mark for expressing our volume being equal to the volume of the cylinder and the volume of the hemisphere, and equating that equal to 6. So we receive our second mark here. We then receive our third mark for getting the correct expression for h, and then we receive our fourth mark for substituting that into our equation here and concluding with the correct answer as we have here. So in part B of this question, we're given some further information. We're told that the manufacturer needs to minimize the surface area of the tank. And we're asked to use calculus to find the radius of the tank for which the surface area is a minimum. So we first recall that we have just shown the equation for the surface area of the tank, and that's given by 12 over r plus 5 over 3 pi r squared. So we know if we want to find a minimum, we're going to take our expression, we're going to differentiate it, and then our second step is going to be set equal to 0, and then our third step is going to be in this case, we're working out to find the radius, so we will solve for r. So we have dA, and we're going to be differentiating with respect to r, and then we have that 12 over r, that is going to differentiate to minus 12 over r squared, and then our 5 over 3 pi r squared is going to differentiate to 10 pi multiplied by r over 3. We then set this equal to 0, and our first step is going to be to multiply both sides by 3. So this will then leave us with negative 36 divided by r squared plus 10 pi r, and that's equal to 0. And then we're now going to get rid of the denominator in this fraction, so we multiply both sides by r squared. So this leaves us with negative 36 plus 10 pi of r multiplied by r squared, which gives us r cubed, and that's still equal to 0. And then continuing this on, we shall add 36 to both sides. So this leaves us with 10 pi r cubed is equal to 36. And we now want to solve for r. So therefore we have that r cubed is going to be equal to 36 divided by 10 pi. And then we can isolate r by taking the cubed root. So we'll have 36 over 10 pi. And then we take the cube root of that, and putting that into our calculator, we get 1.05 meters. So we can therefore conclude that the surface area will be a minimum when r is equal to 1.05 meters. So there was 4 marks in offer in this question. We received 2 marks for differentiating and setting it equal to 0. We then receive 1 mark for getting the correct r cubed expression here, and we receive our 4th and final mark for concluding with the correct answer of 1.05 meters. So in this part of the question, we're asked to calculate the minimum surface area of the tank, and we're asked to give our answer to the nearest integer. So we now have our value of r, for which the surface area will be at a minimum, and we know the expression for the surface area, which is in terms of r. So what we do here is we take our value of r and we substitute it into our equation for the surface area. So doing this here, we'll have 12 over 1.05, and then we will add on 5 over 3 multiplied by pi multiplied by 1.05 squared, and then we put this into our calculator, and this comes out as 17.201 and so on. So therefore, we then have that the minimum surface area is 17 meters squared. There were 2 marks in offer here. We received our first mark for knowing to substitute in a value of 1.05 into our expression for the surface area, and then we receive our second mark for concluding that the minimum surface area is 17 meters squared.